Yeah, so my talk's titled Holy Shit, the Polish Know How to Drink. I hope nobody can tell that I'm still drunk from last night. By Jamie Winsor. Seriously though, thank you so much for having me here. It's been a long trip, but I'm very glad to finally arrive. So I'm Jamie Winsor. I'm the principal author of Bookshelf. I'm also the core team lead. The core team is 3 people. These are them. It's me, Seth Vargo, and Michael Ivey. We work on this tool called Bookshelf. Bookshelf is a chef cookbook manager and a dependency resolver. It retrieves cookbook dependencies for you. It packages cookbooks and those dependencies up into tars that you can give to Chef Solo or upload into a Chef server. And it also has generators and things that allow you to author new cookbooks. It's also now included in the Chef DK, which was released in around ChefConf time. You can install the Chef DK and you'll get Chef and Bookshelf and Knife and a number of other nice tools on your machine, and you don't need to worry about your Ruby version or anything like that. I've also worked on a number of online games. That's where my background comes from. Been wanting to make games since I was a little kid, and I was very fortunate to be able to work on some of my favorites: League of Legends, Guild Wars 2, Terra, Dungeons & Dragons Online, Lord of the Rings Online, and a personal favorite from my childhood, Ashran's Call. Currently, I work on, well, it's an unannounced game, but it's a follow-up to State of Decay. State of Decay is a single-player zombie apocalypse simulator. It's for the PC and Xbox 360. And my primary responsibilities at the studio that makes this Undead Labs is a platform engineer. So I develop the software that makes an online game work. Thing about working at a small studio is that we have to wear multiple hats. So I'm not just developing the account server and the chat server and auth and the distributed routing server. I'm also helping to bring DevOps to the company. We don't have an operations team. And we're crazy, but we hope that we can operate a game without one, right? And we do that by developing the configuration tools and the deployment tools on our own, and educating each other about them. And the engineers, the operators become engineers. So I guess it's a lie that we don't have an operations team, because the engineers are the operations team. So, show of hands, who here has heard of deploy windows? This is when we're going to deploy. All right. And who has those in place at their organization right now? All right. So I could go around the room and ask, why do you think deploy windows exist? But it's pretty much all around risk mitigation. You're trying to make sure that you don't break production because somebody introduced a change. And introducing a change into a system is just a synonym for introducing risk. And that sucks, because you want to deliver what you just created to, in my case, players. But at the same time, I don't want to stop them from being able to play the game. The problem is that not deploying is a risk too. The reason that not deploying is a risk too, other than the fact that your customers don't get to see what you just created, is that graphing risk of multiple changes over time isn't linear. It's actually exponentially harder. So this is fake-ass pseudocode, but it's actually almost saying 6 to the 6th if you had 6 changes. 1 change is like 1 unit of difficulty. 2 changes is like 2 units of difficulty, but as it goes up and goes up, those changes can conflict with each other. So you don't know, especially if also 2 or 3 or 4 or 5 different developers made those changes. So the problem is that if I make a change and I deploy it and it breaks, that's fine. I can quickly fix it. But if I made a change and 5 other guys made changes that conflict with my change, I have no idea why it broke. The problem is that not deploying at 5 p.m. on a Friday isn't robbing Peter to pay Paul. The problem is that not deploying on a Friday to avoid risk is pretty much killing Peter, framing him as a suicide, making his wife your wife, and also adopting his kids as your kids. Hey, I'm sorry, kid, you're mine now. Yeah, I'm daddy. That's basically the problem. So when should we deploy? You should deploy all the time. All the time. Like, are you deploying right now? No? Do you have changes? Go deploy it. Get out of the room and go deploy it. So the thing is, yeah, of course I'm going to release it at 5 p.m. on a Friday. Because Monday, if I have additional changes over the weekend and I hadn't deployed the ones from Friday, I just fucked myself. I have no idea what was introduced over the weekend and what developer did it. So deploy windows are a clear indicator that your release process is broken. So the thing is that we make these deploy windows so that way we don't cause outages. But why is it every time we make something new, there's a potential for an outage? You really need to come up with a way to better mitigate that. So that risk, what about that risk? I mean, that's why we have those deploy windows, right? Well, the thing is that those deploy windows exist because deployment was an afterthought in the first place. And why we create those deploy windows is because it's within our power to control the deployment times. But it's not within our power potentially to to control the fact that every time we make a change, we break production. The thing is that the software that is changed and deployed into production and every time breaks, it's because the software doesn't even want it to be deployed. Every time you go to deploy it, you're just wrestling it. You're trying to say, hey, triangle, go into circle. Hey, square, go into circle. It was just an afterthought. It's like trying to get your kid to go to bed or shut up on a fucking plane. Like, you can't do it. It's impossible. You can't reason with the child because he's a kid. You can't reason with that software because nobody wanted it to be deployed in the first place. It worked on their machine. They loaded up Eclipse, and they hit F5, and it worked. So the question here is, how do we reduce that risk while still allowing for change and rapid change? So we can do that with continuous delivery and DevOps. So continuous delivery is the idea that every time you make a change, it immediately gets put into an integration environment, a development environment, a staging environment, and then it can be promoted quickly to production. And you do that as rapidly as you possibly can. Every single time a commit hits your master branch, you put that into an environment and you test it. And DevOps is the idea that operations and developers are the same thing. So you're not separated by a wall. You don't create something and then throw it over it and let operators take care of it. It's not your problem later. It's not their problem later. Your problems right now don't become someone's problems at 5 o'clock on a Friday. So DevOps isn't a position that you can hold. You can't just rub some DevOps on the problem and it'll all just go away. DevOps is a software development pattern. It's not a position, it's not a team, it's not a department, and it's not an organization. Who here has heard LinkedIn spammers messaging you saying, disruptive startups hiring DevOps ninjas? Like, I get these emails all the time. And I get them and I'm like, fuck no. Bye. I'm not involved in that. I don't want to be anything close to that. And you can't buy a DevOps tool. It's not some snake oil. You don't watch it on an infomercial and you're like, oh, that's going to be great. I'm going to buy that from this enterprise vendor. I'm going to put it in my organization and my deployment problem is going to be all gone. It's not like that. You can't buy a DevOps tool and you can't buy a continuous delivery tool. The reason you can't is because software doesn't solve problems. People do. A really good friend of mine and mentor told me once that if I put the right people in the room, they'll solve the problem the right way. And I think that's completely true. You can't solve one problem with just developers. There's a lot of really good engineers that just sit in Eclipse all day. And I know that I'm joking about it, but they really are good engineers. But they don't know what that looks like in production. And there's a lot of great operators that set up deployment windows because the developers cause them to stay awake or get called or paged or something, because every time a developer makes a change, they break production. DevOps is about coming together. It's about melding developers and operators and doing a little pair programming. Maybe a little sensual touching. I don't know. There might be some time for that. So the thing is that you can't have DevOps without some change. You'll actually need to change your development and release process. You can't buy this tool that fits into your organization the way your organization is today. You have to make a little bit of change. And unfortunately, adopting DevOps is much easier on a new project. So if you start small at your organization, you want to bring it into your organization, do like a hello world program. Your first program when you're learning a language, it's typically hello world. Why the fuck would you change the deployment process on the thing that makes all your money immediately? Or the thing that's the hardest? You know, like I've worked at organizations where I've worked on a game that was very, very large. And the deployment process was a complete mess. And we wanted to change it ultimately, but we tried to start there. And we were successful, but not before we all worked 80 hours a week and hated each other by the end of it. It was very difficult. So try to start smaller and automate and test everything. It's easier to do this too if you have a brand new project, because you can write the tests for the software instead of retrofitting the software that didn't want to be tested, much like the software doesn't want to be deployed. And version, package, and release everything, not just the software. And oh my God, don't build the software on your developer machine and then hand it to an operator later on. Like, I don't know why they think that's okay. Like, developers think that's okay. Oh, I just made this, I tested it nowhere, and then give it to an operator to deploy in production. What? No, don't do that. So let's go through this process. Let's see how to start a new project and keep deployment in mind from day one. So let's build something. And let's go through first an application checklist. We need the source code, of course. Can't have an application without that. You're going to need build tasks like use make or rake or Thor or mix or whatever your build tool is. You're going to have release tasks as well. And you're going to have a cookbook. For those of you that are unfamiliar with Chef, a cookbook is the unit of configuration for Chef. We can talk later about Chef if you're not familiar. And this checklist is going to result in 1, a software artifact, 2, a cookbook artifact, and 3, hopefully you wrote some documentation so people know how that works later on. And if you're the developer, you want to give these to your operations team for every single release. If you're also the operations team, awesome. You guys did an awesome job. So we're going to build this application in a language called Elixir. Elixir is a metaprogramming language built on top of Erlang. I chose this language because it's a compiled language, and I'm very passionate about it, and this is what I'm currently building our online platform in. We're also going to need to install the Chef DK, which is the Chef development kit. This will give you Knife and Berkshelf and a bunch of other really useful tools without needing to manage your own Ruby environment. So the first thing we're going to do is generate the project. We're going to make this project called High Five, because what up? So mix new High Five. We'll make a brand new project called High Five. It actually doesn't matter what we're going to call it, because this is a dummy application, but whatever. We're going to add that to source control immediately. We don't want that just to live on your machine. Then we're going to generate our application's cookbook. This is the third step. The third thing you do is make the cookbook for the application. And it's very important to realize that I generated this inside the source code directory, the directory with the source code, under a folder called cookbook. And I'm doing that because I'm making this part of my deployment, I'm making deployment part of my build process. If you work on a development team, who has like an I broke the build t-shirt, you know? Like you break the build and you're the asshole for the day. And until it's fixed, you don't get to go home. if you break deployment, you're the asshole, and you don't get to go home until you fix deployment. Thank you. It's also important because the cookbook and the application are going to share the same version. So if we open up the metadata of the cookbook, we can see that the version of this is the raw metadata. I'm actually reading a file from the root of the directory of the project called version. And that's going to be generated by one of our build tasks later on in the show. Cool. And then we're also going to read the version, we're going to set the release of the software that we're going to deploy to the version of the cookbook. So this is how we pair them together. First, the version of the cookbook is read at the build time from the version file, and the software is also built with that version. And then the cookbook's going to also say, what's my version? And it reads it like this. It looks into the run context and says, for this cookbook, what current version is it? And then it's going to make sure that it pulls that artifact out later on. We'll get to that. And this pattern that I'm describing right here is called the environment cookbook pattern. We have a couple different patterns in Chef, the library cookbook, the application cookbook, this one. And basically, it's identical to an application cookbook, but it lives with the software when you're developing it. And it also has the Burks file lock included. And it's in version control. And that lock file defines all the dependencies and an explicit lock on each of them. And the reason that this is super important is because we can apply this lock file to a Chef environment. And then all the nodes that join that Chef environment have every identical version of software on them, guaranteed. If you put it in development, it's going to work in production. There's no chance in hell that it's not going to work unless you misconfigure it. That's the only thing that you could possibly do. And then we need these build tasks. So we need 3 of them. We need a version bump. I'm hiding the implementation details here because it's pretty remedial to write these. And it's also gross as shit. Like, if you've ever looked at somebody's build tasks, no one wants to see a 3,000 line make file on the screen right here, right? And I probably can't show a 3,000 line make file. So the first one's mix version bump, and we're going to bump the patch version immediately. We follow semver. So semver is a major minor patch, and every commit that we make, every release that we make, we always bump the patch version unless we know there's breaking changes, and then the developer manually bumps minor or major. The next one's compile, so mix compile, and then test, so mix test. If you used Ruby, these would be rake instead of mix, or Thor, or whatever the software is. There's a build tool for it. And then when we bump the version, what it's doing is it's writing the version file to disk at the root of the project. If you remember the previous slide, the metadata of the cookbook was reading that. So how do we get that compiled software into our virtual machine? And that is the build, package, and release. So another reason why I wanted to choose Elixir or an Erlang type of language is because it's notoriously difficult to make OTP releases. The build, package, and release phase, we basically have to mix, release, assemble, and that'll make the OTP release for us. Package it up and run mix package, which will then create us an artifact for the OS. And whoa, we don't want to deploy on OS X. Why did that happen? Well, because I'm using an OS X machine. And the thing about OTP releases is that it builds one for the OS that you're currently on. So like your build server needs to be the OS you're going to be deploying to. So we actually need to assemble a release for that OS. And how are we going to do that? Well, we're going to build a build server. And we're going to build it with Vagrant. I found a picture of a homeless guy for you, a Vagrant. So we'll build a build server. And the way that we're going to build a build server is with a build server recipe in the cookbook for our software. So it all feeds into each other. So if we look at this recipe, we include some common stuff. We include build essentials. And we're also going to include Elixir, the language itself. And we're going to have Elixir on there because when the build server goes to build a release, we have to include Elixir with the OTP release. So let's open up the metadata and edit that. Let's add our dependency on build essentials and our dependency on Elixir as well. So this is what our metadata looks like for the High Five cookbook now. So with that recipe, we're going to have a Vagrant builder, an on-demand virtualized build server. This is an intermediary step. Screw that word. This is a step before we set up like Jenkins or Bamboo or something like that. This is just the way that we can test and make sure that we can build software for the OS that we want to build it for. And this is a Vagrant file, kind of stripped down to describe what that looks like. When you run Vagrant up, this is going to build the software. So you run Vagrant up from your host machine. This is actually going to build the software for you and output it to the package directory in the root directory on your host machine for the software. I'm going to go back really quick so you can see that really quick. So we've mounted the project's root to a directory called builder inside the VM. And we've done that so that way that when the shell provisioner runs, we build that artifact, output it to that directory, and then on our host machine, it magically appears. So let's deploy that artifact that we have now. So we have this software artifact, and we have our cookbook, and we want to somehow get that onto a remote node. You'll see some serious shit. So let's create the app recipe. This is app.rb, pretty typical recipe. I'm including libarchive, which is a cookbook that I wrote that extracts artifacts. I run it to control the process. And then I've also saying extract the artifact. It's currently at /pkg. Oh, crap, I have a mistake in the slide. Oh, no, I don't. So, and then it's going to extract it to opt high five and restart the service when it's done. So go into the metadata, update the cookbook dependencies, add libarchive. And then we're going to edit our test kitchen file to make sure that we sync that pkg directory when we run test kitchen. And we're going to edit the run list to include high five default. High five default is the default recipe which will include app.rb and any other recipes that we have to make a single release. I'm sorry. Make a single node with all the recipes included to test the cookbook and make sure that it deployed everything successfully. So then we run kitchen converge. This will start test kitchen, run that default recipe, which will run app.rb for us. It will deploy the software by reading from the shared folder on disk that pkg file. I'm sorry, that tar file from the pkg directory. So we now know that we can deploy our software. That worked. And now we need to get that second artifact, the cookbook artifact. We have to generate that. And we can do that with the Burks package command. Running this will generate a cookbooks.tar.gz for us in the package directory alongside the software artifact. So now we have two of the things that we needed to build a self-contained deployable release. The archive of cookbooks contains all those dependencies, and it also contains that Burks file lock, which is very important because that's the thing that we're going to use to apply to a chef environment to then deploy everything throughout dev, prod, or test and promote it. So we have those two artifacts now, and hopefully you wrote the documentation. I'm not going to go through that. Where do we put those? You take those artifacts, you put those in an artifact server. An artifact server is something like GitHub or GitHub Enterprise, Sonatype's Nexus, Artifactory. It could even be a raw HTTP server that has authentication on it if you're poor or something. Oops. So I prefer GitHub releases and release artifacts. This is the Burkshelf API project, and it follows this pattern. And each release is updated, and you can see that both artifacts are attached to it, the Burkshelf API.tar.z and also the cookbooks. So now we have those up on our artifact server, and our cookbook is deploying just from like this local deploy, like on our machine, right? But what we really want to do when we go to production is pull the artifacts outside of the artifact server in the cookbook. So let's use GitHub deploy. If we open up our app recipe, I've slightly modified it to say, if I'm doing a local deployment, don't pull it out of GitHub, and instead my artifacts on disk. This is for testing purposes. And if I am not doing a local deploy, go to GitHub, pull the artifact out, put it on disk, and then let's extract that. So let's update the kitchen YAML file and add an attribute that says local deploy is true. Because when we test our cookbook, we want to test the cookbook for the software that we're currently working with and not software that we previously released. So add underscore local deploy to true. So with these release artifacts, they allow us to build a brand new environment from a specific version. They allow us to upgrade pre-existing environments, and they allow us to promote through logical environments. The tough thing here is that I'm using the word environment a lot for three things. One is a logical environment. It's what you think of right now with dev, stage, and production. Two is the chef environment, which is something you make. It's actually a thing on the chef server. And then three is this environment cookbook pattern. So it's a little overloaded and could be a little confusing. So now we have these release artifacts. We're going to take those and we're going to deploy it. We're going to create a brand new environment. Knife environment, create high five dev. So this is our logical dev environment, but it's for our application high five. So we create the environment. And then we're going to bootstrap a node to it. And we do that with knife ec2 server create. This is kind of like a shortened version of it. But we're basically creating an instance in AWS, and we're adding it to the high five dev environment with an empty run list, just to make sure it's bootstrapped that has chef on it, and we're good to go. Now what we want to do is upgrade that or deploy onto it the software that we just created from our build server. And we're going to use a tool that I created called Workflow. Workflow is a cookbook-centric deployment workflow tool. This was extracted from a bunch of build scripts that I had that deployed our software at Undead Labs. And it was created so that way I could show a good user experience for how to deploy software. This is not my crown jewel of software that I've built. There's not even a test written for it, right? It works, and it works on small scale, but it exists to demonstrate how a deployment should look. Not exactly deploy. I wouldn't use it for large-scale stuff just yet. So you can install Workflow with chef.dk by running chef gem install Workflow and adding the embedded bin to your path from chef.dk, which will then give you the below command, BLO. Make sure you install chef.dk before you do that. And with the below command, you can install the cookbook artifact into your server. So previously we published, I actually missed a slide. So when we created those artifacts, what we wanted to do was publish those into our artifact server. And in this case, we're using GitHub Enterprise or GitHub. So we below install the URL, and it will take those cookbooks and put them into our chef server for them. You can actually shorten the install command to in. So you can blow in and then the artifact, like a Nintendo cartridge. And then you want to upgrade the chef environment. So you blow upgrade the name of the chef environment, the name of the application, and then the version of the software that you want to upgrade to. You can also leave it off. It'll just do latest, or you can say latest. And you can even shorten that to blow up the environment. And that gives you a one-button upgrade. That's the user experience I'm looking for, right? So the thing is that even if you get this process right, and you know it's the right thing to do, I'm going to get off the slide because it's aggravating shit out of me. Change is really hard. especially when you're at a large organization. You want to be a catalyst for that change. But the problem is, don't expect a parade. It's not coming. And even if it does, you're not going to have your own float in it. No one cares that you're the guy that came up with the release process that's going to solve everyone's problems. Everyone will remember the end result, and everyone will just forget that journey there. So if you're going to be the catalyst for change, understand that it's a tough job, and it's going to take some time, especially if you don't have the luxury of starting with a brand new project. But I can tell you that at the end of it, you'll have a one-button upgrade. You could do this. This will happen. If you meld development and operations together, you get everyone on the same page, you identify a project that your organization currently has that's new or small, and workshop it there. And that change that you create and that experience that you create, people will look at and say, can I have that? And then you'll say, you sure can have that. And as soon as people start asking you, can I have that? That's when you've succeeded. When everyone in your organization comes to you and says, I love how this tool gets deployed, and I love that there's no outage, and I love that we deploy it at 5 o'clock on a Friday and no one fucking cares and no one gets woken up on a Sunday, everyone is going to come to you and ask for that. And that is how you do DevOps right. So this is the obligatory, do you want to make games slide? Do you want to come work with me? We're hiring. We're located in Seattle, Washington. We're looking for game programmers, game producers, game animators, and designers right now. If you're an operations person, you qualify as a game programmer. You already have the skills necessary to do that. You just need to learn the side of like making games. But you already know the side of like how to operate a game, even if you've never done it before. You can contact me on Twitter or GitHub, and that's the end. So questions? The lights are very bright. I can't see anything. No questions? Okay.